Here is the answer for the Day 4 bell work. Evaluate each answer and round to the correct number of digits. In chemistry class, unlike math class, you're not going to be told a certain number of digits to round to. Instead, you have to figure out on your own how many digits to round to. And there's a correct way to decide what to round to. You don't just get to round to anything you want to. You have to round based upon the measurements that are in the situation. In chemistry, we're going to assume that all measurements that are mentioned are from actual measuring devices that have a certain level of precision built in. For instance, when you measure the mass with triple beam balances, those triple beam balances are precise to the hundredths position, that is, 2 numbers to the right of the decimal point. Or when you're measuring temperature on a thermometer, the thermometers that we'll use are precise to the 10th of the degree, or 1 number to the right of the decimal point. It's the capability of the measuring devices that determine to how many digits you can write out an answer, and in turn, how to round off answers when you're doing math problems. So question A, we want to add these 3 links together. Now the actual adding is probably best done on a calculator. So let me type that in. 12.6 plus 3.07 plus 12.511 makes 28.181. Now your math teacher would probably be perfectly happy if you gave an answer like that, but this is not good enough in chemistry class, because writing an answer like this seems to communicate that the measuring devices that were used to measure all those links were precise to 3 decimal places, that is to the thousandths position, and that's not true. Only one of the measurements, this last one, came from a measuring device that was able to measure out to that many decimal places. These other 2 measurements weren't so precise. Whichever measurement in a math problem has the least precision is going to limit the precision of our final answer. So we're going to round our answer based upon that fact. It is this first measurement that is the least precise. It only has 1 digit to the right of the dot. This one has 2 digits, and this has 3 digits. Because this measurement has only 1 number to the right of the dot, our answer can have only 1 number to the right of the dot. And so we have to round off to 28.2 centimeters. Please notice as well that on a math problem, I'm making sure to include the label for the unit of measure. Now question B, we want to do a multiplication problem. One thing I notice is that milligrams is going to cross-cancel with the milligrams under that bar. Let me slash those out. Now I see that my label that's left is the word particles. Now for the actual multiplication, a calculator would be best. 40 times 12.6 is 504. And our unit label is the word particles. But we need to check to make sure that we're giving our answer with the correct amount of precision. We don't want to miscommunicate how good our devices were. Our first measurement came from a measuring device that gave an answer with only 1 significant figure, the 4. The 0 is simply a placeholder. The other measurement came from a better quality device. This has 3 significant figures. But whichever one is least precise is going to limit our final answer. Because the first number has only 1 significant figure, the 0 is just a placeholder, our final answer can have only 1 significant figure. We need to round the 504 to just 500 particles. Now question C, another multiplication problem. And I notice the label liters will cross-cancel with the liters that's under the fraction bar. Let me slash those out. Now the unit label that remains is moles. The actual multiplication can be done on a calculator. And the result is 0.1281 moles. But again, we want to communicate our answer with the correct amount of precision. We don't want people to think that because our answer has 4 digits to the right of the dot, that we were actually using tools that measured precisely to the 10,000ths position. Let's take a look at the measurements that were used in the math problem. This first one has 4 significant figures. The number does end in a 0, But unlike the previous number, the 40, which ended in a 0, this 0 is to the right of a decimal point. That communicates that the device that was used to create that measurement was actually accurate to that many decimal places. This measurement here has 2 significant figures. This number has some zeros, but notice how these zeros are at the beginning or the left end of the number. These are placeholder zeros. This number is 42 thousandths. That 42 has only 2 digits. Whichever of these is least precise is going to limit the precision of our answer. And that's going to be this one right here, which has 2 significant figures. Our answer can only have 2 significant figures. So we need to round this to 0.13 moles. To do the actual rounding, I followed the same rounding rules that you learned in math class. I decided how many digits to keep, 2 of them, because of the 2 significant figures, and then I looked at the next number to see if it was 5 or higher. And it was, so I changed that number to a 3 and dropped off the other numbers.